on. Alright, so let's talk a bit about the discriminant. So the discriminant is also quite a useful measure both for methods and for spec. So what it is it's essentially used in a quadratic equation, and it's used to determine how many solutions we really have in a quadratic equation. So it's really, really important both in methods and spec, so it's good to have a lockdown on the knowledge of this. It's also quite useful for predicting whether a graph has real or complex solutions, because if it has complex solutions, we can kind of look into that further when we get to complex numbers. But it is possible to solve basically any quadratic if you're able to use the complex universe as well. But not all graphs will have just real solutions. Some graphs will only have those complex solutions, so it's important to note that. So the rules that we have here, so for ax squared plus bx plus c, the discriminant we get is that it's b squared minus 4ac. So if that, and that's kind of just derived from the quadratic formula, so x equals to negative b plus or minus b squared minus 4ac over 2a, right? You can see that the b squared minus 4ac part is the part under the square root, so that kind of gives you a sense of why it has to be bigger than 0, because if it was smaller than 0, therefore your square root wouldn't exist, and if your square root doesn't exist, then your overall solution also doesn't exist. So therefore that's why we have to make the discriminant bigger than 0 for that. Now if it was smaller than 0, we can't have a negative surd, so that unfortunately does not exist. But if we have an equation which is just one solution, what we will have is just b squared minus 4ac should just equal to 0. Should equal to 0, right? And why that is because when it will only have solution is because that part equals to 0, it will no longer have that plus or minus function, so it will kind of just be the negative 6, or the negative b in this case, the negative b over 2a. So basically the position of the y turning point will tell you where the solution is, as long as the graph hasn't been horizontally translated. Alright, so the first one is prove that there are always real solutions to the equation shown below. So first of all, we're going to try and work out what b minus 4ac is equal to. So ignore the actual b's and c's in here, and we just need to focus on copying it accurately across. So it's a plus c squared, so 4a plus c all squared, and then we'll have minus 4a, which is going to be negative 8 when we bring it to the other side, c, which is negative b squared minus 2ac. So therefore what we'll get from this is that we'll get that this is going to be 16a squared plus 8ac plus 16c squared plus, is it plus? Sorry, let me just rub it out. So we'll get that this is going to be 16a squared, this, and then we'll have here that this is 4ac, so b squared minus 2ac. So this is going to be 8ac, and then we're going to have plus 16c squared, right? Okay, and then we'll have plus 32b squared minus 2ac. Okay, so then what we have to do is kind of complete this equation that we've got here. So that's going to be, so 4ac, negative 4ac, and then we have minus 8 minus this times by this. Okay, so we're going to end up with 16a squared plus 32, sorry, not 8, 32, so that's going to be 16 times 8, So that's going to be quite big. So it's going to be 16 times by 8, because we'll have this. I think I only times half of it by 16. Whoopsies. So let's just make the 16 on the outside and then times it in, rather than doing that. 16a squared plus 2ac plus c squared plus 32, all of that. So we'll get that this is 16a squared plus 32ac plus c squared plus 32b squared, and then we'll have that this is going to be minus 2ac, so minus our 32 times by 2ac, which is going to just be 64. Minus our 64ac, right? Okay, so we get a squared, so we get that this is going to be 4ac squared, so we'll get 16a squared plus 2ac plus c squared, and then we'll have minus 4ac, so minus 4, negative 8, 2ac. Okay, cool. I have a feeling that this question was meant to be, so it's just ac, but that's right. Let's have a look at what we would get in the end. So we would end up with 16a squared plus c squared, plus 16c squared plus 32b squared minus 32ac, right? Okay, so then we have to kind of predict what's going on here. I think that what was meant to be going on here is that this b squared minus 4ac component, that should have been, because that's going to be your a, and then when you times it by your your negative 8 there, we can see that I think the idea of it was that the b squared should have cancelled out, so sorry about that. We'll just pretend that this is ac instead, because there's not always going to be real solutions to this, because if there was always real, there's only real solutions if we know 16a squared plus 32b squared plus 16a squared, if we know that that is going to be bigger than 32ac, because potentially we could have had a, b, c all equal to just to 1, right? Or yeah, it could all equal to 1, it would still be overpowering, wouldn't it? But that's right. So essentially, if we pretended that this was just AC, so that we got 4AC, so we have b squared minus AC, so therefore we have 32, right? AC, and if we kind of write that in, we'll have that this is 16a squared plus 16c squared plus 32b squared, right? And we can say any number squared is bigger than 0, so therefore we will know that this discriminant is always going to be bigger than 0. Okay, so we need so for the conditions for only one solution, right? If we consider something like 16a squared plus our 16a squared plus our 16c squared plus our 32b squared. That was our our solution that we had there. So if we kind of consider that and we just need overall one solution that to work with, then what we can be considering is that we would need a to equal to 0, b to equal to 0, and c to equal to 0, right? Because that's really the only possibility for us to get one solution for this. Otherwise we'll always have more than one solution, because nothing squared should it be equal to that. Alternatively, if we kind of follow the old one and we had 16c squared plus 32b squared, right, minus 32ac, all of these would, by any number, if they are not 0, they are always going to be greater than 0, right? So this is going to be the positive component, and this is going to be the negative component. So we can kind of simplify that down to saying that that's c squared plus b squared plus 2b squared, minus 2ac has to equal to 0. So if we can kind of take that out, that would mean that we need, in some form of the other, when we're trying to solve for something, that's the kind of the relationship we need. So that's the relationship we need between all of those numbers, right? So if they're all non-zero numbers, that's the relationship we need between the numbers. Cool. All right. So let's try this with the smallest positive integer, so that 3x squared plus px plus 7 equals 0 has real solutions. So what we want to do here, once again, we want discriminant b squared minus 4ac. So therefore, we'll get that this is p squared minus 4, 3, 7, right? And we'll get this is p squared minus, so that's 12, that's 21 times 4, so that's 42, and then 84, so p squared minus 84. So if we want this to have real solutions, we need p squared minus 484 to be bigger or equal to 0, right? So what that actually means for us is that p squared has to be bigger or equal to 84. So if we consider like our graph of p squared, right, let's say 84 is here, that will mean that if we try to solve p squared equals to 84, we'll get that this has to be p is equal to plus or minus, and we can kind of use the roots that we've undone here since we've already have that here. So it should just be 2 root 21 in terms of the roots of it. So therefore we can kind of see that this is going to be negative 2 root 21, and this is going to be positive 2 root 21. And this is just a general tip for like any inequality where you're not using a linear equation. You must always just kind of graph it out, because once you graph it out, you'll actually be able to see what's going on in the overall perspective of what's going on. Because if you don't graph it out, there might be unexpected turning points or things which are going on which you don't really foresee. So when we look at this, we'll get that this is 2 root 21, and this is 2, so this is negative 2 root 21, this is positive 1, and because it wants the smallest positive integer, we're only looking at this side, and we need 2 root 21, right? Okay, so because we're looking for an integer value, this third must be, in order for us to be like, for p squared for this to be greater or equal to 0, it must be past that point, right? And because we're looking for an integer value, we need to look for this third to be an actual value. And the next closest one where we get an actual value will be 2 root 25, right? Because if we go backwards to 2 root 16, that will be under here, so that will mean that p squared is not bigger than 84, so we won't be able to have a sufficient number. So the next closest number will be 2 root 25, which is essentially just 2 times 5, which we get 10. So the smallest value of p, smallest integer value of p, is going to be 10, right? Cool. Alright, let's move on. So then if we kind of look into here and we want, so now if we want the equation of x squared plus 4kx plus 3k, where k is a constant, has distinct real roots, and we want to prove that k bracket 4k minus 3 is bigger than 0. So what will happen here is, once again, we are talking about the roots and kind of what's going on. So because we're trying to talk about the roots, essentially what we have to do is talk about what the discriminant is first, right? So the discriminant for this question would once again be b squared minus 4ac. So we can pop everything in, so we get that this is going to be 4k squared minus 4, 1, 3k. Okay, so then we'll get that this is 16k squared minus 12k. Alright, so if it needs to have distinct real roots, so real roots, because it has an s there, that means that we need 2 roots, right? So when we need two roots, remember discriminant has to be greater than 0 for two solutions, right? So that what that means is we need 16k squared minus 12k to be greater than 0. Okay, so we can take away the 4 and we'll just get 4k squared minus 3k has to be greater than 0. So we'll get that k, 4k minus 3 has to be greater than 0 as we needed. Right here. Alright, one more. So it has to find, you want to find the set of possible values. So we're using our equation from before. So we need k, 4k minus 3, I think it was. Yes, has to be greater than 0. So once again, if we kind of expand that out, 3k, and we wanted to draw out, because remember our inequality is with something which is not linear, so we must draw it out. So we can kind of note here that it's going to go through 0, right? And the other intercept that it's going to go through is 3 on 4. We note that it's a positive graph as well, so we can kind of draw it something like this. So we go through 0 and 3 on 4. So you can kind of note how it travels in both directions, and it wants the possible values of k. Now there's a number of ways that we can write possible values of k, and it doesn't really matter which particular way you write it, as long as you write the correct gist of it, right? So you can either say k is greater than 3 on 4, or k is smaller than 0, or you can write k is 3 on 4, so k belongs to 3 on 4 to infinity union with negative infinity to 0. Remember, all not including, because we can't include 0 here. And then also we can also write it as k is r except 4, and we include these values because we have to exclude them from our equation, 0 to 3 on 4. So those are kind of 3 different ways to write it, and we would have talked about this, I believe, earlier in the year in the January lectures, potentially, on how to convert between the different sets and talking about the different notations. So just make sure you're comfortable with the different notations, just in case they actually ask you to put it in a specific form. For example, if they said put it in the form R except from A to B, and you would be a bit stuck if you didn't really know how to convert through the forms. So just make sure you know how to write equations both in set and interval notation, because I find both of them are appropriate for different scenarios, right? I find that the inequality or kind of that type of notation is more helpful when you're solving for things, and because you can directly see what's really going on, whereas I find the interval notation a bit cleaner to work with, so that at the end it just looks a bit cleaner as an answer, in my personal opinion. But it's up to you which part, which way you use it, really.